Well, it would be along x-axis, positive x-axis. Again the same problem. If the dipole is like this, suppose minus q and plus q, this is the perpendicular bisector position. So if I ask you what would be the electric field due to this dipole at this point P, then would it be along x-axis? No. So the idea is this would be, unlike the previous case, it would be along minus vector P. See this picture, minus q to plus q. What quantity happens to be along minus q to plus q? It is dipole moment, vector P. What has been the direction of resultant electric field? Plus x-axis, plus I hat. Isn't it that the resultant electric field is just opposite to vector P? So, if this is the orientation of the dipole, then it is having its dipole moment from minus q to plus q in this direction, vector P. So, opposite to this is this, but parallel to this, let us move this pen, parallel to this, but not in this direction, rather in opposite direction, like this. So, this would be the direction of this electric field E on the perpendicular bisector position for this dipole. So did you get the point, the meaning of along minus vector P? It is having vector P here, move parallel to this and just reverse the direction. Another example, suppose the dipole is like this, minus q plus q. This is the perpendicular direction. Can you understand what should the direction of its electric field be? Try to think it. Yes, it will be along this direction at point P. Why? It is having dipole moment from minus charge to plus charge, vector P. So, its dipole moment, its electric field at any point would be parallel to this, but opposite in direction. So, this would be its electric field for the perpendicular bisector position. Finally, we got the idea of its magnitude and direction. Finally, for a short dipole, obviously you put this point if the derivation of this comes in your exam. Put this point also as an extra point, a special case. What? For a short dipole, again for the same reason, L is very short, very less than R. Then we will put L square to be 0. So how much does this become? E for very short dipole at a point on a perpendicular bisector position would be given by K, okay, P divided by L square is 0. So only R square to the power 3 by 2. So this is the formula. E equals to K, P by RQ. Let us now summarize what we learned. We learned what is an electric dipole. Then we learned its dipole moment, which was directed from negative charge to positive charge. After learning that, we found electric field intensity due to a dipole at its axial position and on its perpendicular bisector position. So intensity at an axial position was given by, remember the formula, E equals to K, then 2P by R square minus L square whole square. And for a short dipole, it was given by K, 2P by RQ, where L was very short. We put 0. Then came the formula of electric field intensity at a perpendicular bisector position, where the formula came to be E equals to K, P divided by R square plus L square whole to the power 3 by 2. Now remember here, R square plus L square and power 3 by 2. It also had a special case where for a short dipole, its intensity was given by K P by RQ. Half of that was at the axial position. Now try to remember those formulas, write them down, and I'll suggest to derive those formulas before you start Gaussian